Hey yo, what's cracking legends? Today we're going full Sigma mode and snatching SSL TLS packets like it's nobody's business. Using Wireshark, of course. If you're trying to be that tech savvy giga chad, you better stick around for the whole vid. Real talk, like 85% of you are watching these vids without subbing. What are you doing, bro? Hit that subscribe button right now if you want to join the squad and let's go. Time to drop some Giga Brain intel. SSL, now rebranded as TLS, is the supreme bodyguard for your online data. Keeps it locked up tighter than a Sigma male's emotions. Runs on transport layer, layer 4 in the OSI model. And here's the T. You can spot an SSL TLS secured site if it's got HTTPS instead of just plain HTTP. No padlock, no party. Now the SSL TLS handshake, this is where the real riz comes in. First, we hit up a three-way TCP handshake to set the vibe. Then the client hits the server up with a client hello, like yo, what's up? And the client server's all, here's the server hello back. They're basically sliding each other their crypto keys like it's some top secret handshake. So after the hello messages, the server goes Sigma and drops its public key to the client. Clients like bet and uses that to create a secret key for their convo. This key is just for them, no one else can slide in. Then the client double checks the server's legit by verifying its certificate. Once that's clear, they lock down the connection with that secret key. They're chatting securely, no eavesdroppers allowed. That's the SSL TLS handshake in a nutshell. Bet? Let's dive in. Okay, I'll stop the recording for now. Alright guys, what's up? In today's video we're basically going to capture SSL or TLS packets in Wireshark. Also, this setup is going to be specifically for Linux machines since our practicals are going to happen in Linux, at least for PICT. And if the setup for Linux and Windows is way different, so if you are using Windows, please don't watch this video, this will just waste your time. Okay, so first, now that this is out of the way, first of all, open your terminal and type in sudo wireshark like we did in the last video. You can check that out where we just went through like the basics. Right, so Wireshark is on now, and over here you can go to file and edit. Where in configuration profiles, I've already configured a TLS profile just to capture TLS packets. Basically, you can add various different colors over here to the packets. So, and you can do all sorts of customizations just for that specific profile. Okay, for now I'll just go to default. If you want, you can add a profile by clicking the plus over here, doing like a TLS1 or TLS V1 or anything, and like you can configure that from there on. Let's just select default for now. So we have default over here. Okay, then I'll go to preferences to show you something. Over here in preferences, you go to protocols and you can search for TLS. Also, a lot of people try to search for SSL, but the thing is, if you're using the latest edition of Wireshark, you should know that there's no such thing as TLS. I mean, sorry, SSL. There's no such thing as SSL because SSL in itself has been deprecated now. We use TLS instead of SSL, right? You might have seen there was this path over here where SSL keys.log is given. We'll get to that later in the video. We won't be using any of this. We just will be using this master secret log file name to decrypt the data. Okay. Other than that, we'll close this up. We'll go to our driver or device over here. it has started capturing something. Capture the SSL and TLS packets over here. So I'll just stop this right now and I'll go to Wikipedia, right? So I've opened up Wikipedia. I'll restart the capture. I'll reload this. Okay. Yeah. So now we have a proper this. So the here is the TCP SYN and acknowledgement. Then there's the client hello, which goes to upload Wikimedia dot. So this is what goes from my device to the server. So this is the IP address currently of my device on my network. Also, many people think that it's, oh my god, he's exposing himself on the internet by sharing his IP. This is allocated by my router using DHCP. So it is going to change on a daily basis. So it doesn't really matter. It doesn't really matter. Okay, so this is the destination IP address over here of the Wikimedia servers, which is what is hosting Wikipedia. And over here, you can see there's a bunch of random data given. So here, there's the handshake protocol first, like the message said. See, this is the content handshake type. This is the next one is for the version. This is the length. Like we said, client hello handshake type. This is the length. The available version 1.2 on my device, right? Then there's this random ID, which is and this is just a random sequence of characters. This is the session ID. Also, this session ID, which has a length of 32, is going to be used to refer like this particular session. So this is like the identifier for the given session. Nothing really important in this. That it should be safeguarded or anything. Then this is cipher suit length. So I'll open this. So over here, all of these are basically what the security, encryption algorithm, and hashing algorithm. So let's say I'll take one over here. So this is TLS, which is encrypted with RSA and AES 256, and the hashing algorithm is SHA or standard hashing algorithm. Right? They have their own hex codes, which are represented like this. There's Chacha 20 hashing algorithm, AES, sorry, not hashing algorithm, Chacha 20 encryption algorithm, AES 128, RSA modified with some other variants, right? And then that's pretty much it though. Like, so what happens is my computer is going to send the list of hashing algorithms it can perform, and the server will pick one out of these 17 suites. Then there's a compression methods. So only one method of compression, which is null. There's the server name, length 25, host name. This is your server name. So you definitely know that this is from wikimedia.org and you're not getting fooled. These are just other extensions. And then there's the encrypted client hello. We can't really see this right now because this content is encrypted. We need like the pre-master keys for that, which I'll show how to get later on in the video. So this is the client hello. Then we have the server hello. So I'll open this up. Right, these are the starting bits. Then there's the server hello. There's the session ID which is generated, and this is the cipher suite which the server picked. It picked the TLS AES 128 GCM algorithm. Again, no compression, and you can see extended supported versions TLS 1.3, but it's using 1.2 because my device supports TLS 1.2. Other than this, there's like a few other information which are not really important right now. Right, so this is the server hello and the client hello. Then we have the chain cipher spec. Right, so over here happens is the session keys are generated in this, and there's going to be a key exchange as well, where my computer will generate a private key using the server's public key and some other parameters. Actually, we can't see a lot of this data just because it is encrypted. So what we are going to do now is going to decrypt this data using the pre-shared, basically the SSL keys, which we can store in a log file. So let's just stop this for now. I'll stop capture. I'm not going to use normal Mozilla Firefox. I'm going to go and I'm going to open Firefox developer. So you'll have to download this. You'll have to download this for your device if you want to look at this on Linux. Then about, I'll go to config, and over here you have to set. So once you type this, you will get like a similar icon. You press on plus, the boolean value, and you make sure that this value is true. You can switch this using this icon and make sure that this is true. Then close this and open up a new terminal. Over here you have to type export SSL key log file, and you have to enter the path. So /home /$user, and you have to put in the name SSL key .log. Okay, it gave us an error. That's because I missed out the equal to sign. You have to put an equal to sign over here. Yeah, so this is basically setting an environment variable in Ubuntu. This sets an environment variable, and after you've done this, use the same terminal to open Firefox Dev Edition and put an and over here. Right, I'll open this up. I don't want it to be the, if I open up my, yeah, see there's an SSL key.log over here where there has been some random client server secrets over here. I'll just clear this up. Let's go to Wikipedia and we'll check. So there's some files secrets that are written in here, and now this should be ideally filled. Okay, this is filled with some secrets. So this is what we are going to use to decrypt the traffic. Okay. If like for some reason the file isn't filled, like it is coming up empty or something, just try it again. It will eventually work. Now what we'll do is I'll go and edit preferences, protocols, extend this and search for TLS. You can just press T and it will go to the T wala column. Right, so TLS. Yeah, so open this. Okay. Now we'll have to restart the capture again because these keys and those keys are probably different. So I'll start capturing, continue without saving, and I'll reload this site. Okay, so I've just restarted the whole thing, and you can see over here there's the client hello to Wikipedia, right? There's two reassembled TCP segments. So TLS version, I've sent the cipher suite, the session ID, the server name. It's Wikipedia only. See, and in this packet, now that we have the decryption, we can like actually read the text. And there's the H2 HTTP 1.1 version. Then this is like the truncated key, which we can see, and a few other fields. So that is the first one. the client hello, then we have the server hello, chain cipher spec, and the other part, which was the encrypted extensions. And you can see over here we can see the decrypted TLS as well. So yeah, you can just go and check. So the server has selected the same TLS AES 128 GCM algorithm again. No compression method, 46 extensions supported. So yeah, if you convert 2E from hex to decimal, it comes as 46. All of this information has come from the server. Then there's the supported 43 versions, which is 2B. The length is 2. Supported version again, key share, and all other details. So there's the certificate verify. So this is again sent by the server. The server will send the certificate to the client, and it will like verify it. So see, handshake protocol certificate verify. There's the signature algorithm, and that's the signature for the certificate. So I'll just go to reassembled TCP, and let's see, decrypted TLS, right. Over here we can read Wikimedia Foundation Inc. of which is the actual certificate for Wikipedia, right? Dot star Wikipedia, Wikidata, and all other text which we can read now thanks to decryption. And after all of this is done, we can see the server says that the handshake protocol is now finished. Like the channels and stuff is secure now, so there's no need for doing it over and over again. And yeah, that's pretty much it. After that, there's the chain cipher spec, which is I believe sent from the client to the server. Yeah, so it's sent from the client to the server. This is my IP, this is the server's IP. And so basically over here the private key is generated. So yeah, and after the private key is generated, there's one private key on client side and server side. So using those two, the data is encrypted and decrypted, and there's like secure communication. There's again there's some headers. Yeah, see, method get path Wikimedia org assets ing Wikipedia logo, then the authority wikimedia.org. You can read all of this data. So this data is then sent to your browser, and it makes like your home page or whatever web page. Right? You can read this over here as well. This is like all given. This is the full request URI and other data. Using the same method, you can look at all of the various different headers and stuff. So that's pretty much it. I mean, we have decrypted the data, and just ignore all of this. This is like the extensions which I use. Even they sort of send like HTTP requests, so that's why. But yeah, that's pretty much it. If you like the video, press like, smash subscribe, and see you in the next one.